Imagine standing on sand dunes that stretch to the horizon, knowing that beneath your feet lie the fossilized bones of hippos and crocodiles. The Sahara wasn't always a desert. 10,000 years ago, rivers wider than the Thames carved through grasslands where elephants roamed and fish jumped in crystal waters. What force could turn a paradise into the largest hot desert on Earth? Between roughly 11,000 and 5,000 years ago, the Sahara Desert was a vast green landscape crisscrossed by rivers, lakes, and wetlands that supported thriving human civilizations and diverse wildlife. Scientists call this period the African Humid Period, and its discovery has rewritten our understanding of human migration, climate change, and the fragility of ecosystems. The transformation from lush savanna to barren desert happened in geological terms almost overnight, and the hidden rivers that once flowed there hold clues to how quickly our planet's climate can shift. This matters today because we're living through another period of rapid climate change, and the Sahara's story is a warning written in stone and sand. Understanding what happened to these ancient rivers helps scientists predict future climate tipping points and shows us that even the most dramatic landscapes are temporary. The story begins around 14,500 years ago when Earth's orbital tilt shifted slightly, bringing summer monsoons further north into Africa. This change seems small on paper, just a few degrees of axial variation, but it triggered a cascade that transformed an entire continent. Rain began falling on the Sahara in quantities we can barely imagine today, filling ancient riverbeds that had been dry for tens of thousands of years. By 11,000 years ago, the African Humid Period was in full swing. The Sahara bloomed into a network of interconnected river systems, some of which have left traces visible only from space using ground-penetrating radar. What is now a barren ocean of sand once mirrored the lushness of the Serengeti. These vast rivers supported lakes teeming with fish, hippos, and crocodiles. Herds of gazelles and elephants grazed along fertile floodplains, while early humans built settlements along the banks, fishing, hunting, and carving rock art that told the story of a landscape now lost beneath dunes. The largest of these rivers was the Tamanrasset River, a colossal waterway that flowed from the Atlas Mountains through what is now Algeria, emptying into the Atlantic Ocean near Mauritania. Modern satellite radar, first analyzed in the 2010s, revealed that this ancient river once drained an area larger than France. Further east flowed the River of the Gazelles, connecting to Lake Megachad, a vast inland sea that once covered 400,000 square kilometers, larger than the Caspian Sea today. Sediment analysis confirmed its scale, revealing evidence of hippos, crocodiles, and thriving human settlements clustered along its shores. Even the Nile River was dramatically different. During the Green Sahara, several now-vanished tributaries from the west fed into it, carrying monsoon waters from the Saharan highlands. Geological data show the Nile's flow may have been 3 times its modern volume, supporting dense human populations and early agriculture across its broad floodplains. Scientists used satellite-based radar to peer beneath the sands and uncover ancient riverbeds preserved for millennia. The branching patterns matched those formed only by flowing water. Ground excavations then revealed freshwater mollusks, fish bones, and aquatic plant fossils, unmistakable proof that rivers once coursed through this now barren land. Field expeditions later confirmed what satellites had seen. Geologists uncovered sediment layers filled with freshwater shells, fish remains, and even traces of flood deposits. Undeniable evidence that these ghost rivers once flowed with life. Each discovery revealed another piece of the Sahara's hidden history. Around 8,000 years ago, the monsoons that had nourished the Sahara began to weaken. The same orbital forces that had once brought the rains started to reverse. Summer sunlight over the northern hemisphere slowly declined, pulling the tropical rain belt southward. The great rivers still flowed, but their strength began to fade. At first, the rivers became seasonal. Their once mighty channels shrank to narrow streams, and lakes that had stretched to the horizon began to retreat. Grasslands gave way to scrub. Dust once again started to rise from the earth, carried westward by the wind. Between 6,000 and 5,000 years ago, the decline accelerated. Scientists believe the Sahara crossed a climatic tipping point, a moment when vegetation loss triggered a feedback loop. With fewer plants to release moisture into the air, rainfall dropped even further. The land dried, and desert sands began to reclaim their ancient territory. Climate models show that this shift didn't take thousands of years. It happened in pulses. Periods of drought struck faster and harder, and within a few centuries, the Sahara's transformation was complete. Forests disappeared. The rivers vanished beneath waves of advancing dunes. Paradise was gone. By 4,000 years ago, only isolated oases remained. The last crocodiles and hippos found refuge in underground-fed pools where the ancient rivers still touched groundwater. For the people who once lived here, survival meant migration or extinction. Archaeological evidence tells the story of this great migration. As the Sahara dried, entire communities moved east toward the Nile Valley or south into the Sahel. They carried with them knowledge of fishing, farming, and animal domestication, seeds of new civilizations that would soon flourish elsewhere. Those who reached the Nile joined other groups along its fertile banks, helping to shape the foundation of ancient Egypt. Many Egyptologists now believe the Green Sahara's collapse was one of the key events that set the stage for the rise of the Nile kingdoms, a rebirth born from climate collapse. Rock art scattered across the desert preserves the human memory of that vanished world. Paintings and carvings show hippos, elephants, giraffes, and even people paddling boats. These weren't myths. They were snapshots of daily life in a time when the Sahara was green. As the climate worsened, the art changed. Later panels depict cattle and goats instead of hippos and gazelles, animals better suited to arid life. Then the images stop altogether. The artists had moved on. The desert had won. Even after the people left, the desert kept its secrets. For centuries, no one knew the rivers ever existed, until science learned how to read the sand itself. Beneath the dunes, ancient channels still twist like veins through the bedrock, their shapes revealed by radar from orbit. Modern satellites using synthetic aperture radar can see beneath layers of dry sand, mapping buried river systems invisible to the naked eye. The branching networks they revealed weren't random. They followed the unmistakable patterns carved by flowing water. Ground surveys confirmed it all. Teams digging into ancient floodplains unearthed rounded stones that could only have been carried long distances by powerful currents. In the same layers, scientists found freshwater fossils, mollusks and fish bones from species that can't survive in desert conditions. Each discovery was another undeniable clue. To determine when the Sahara finally dried, scientists used a method called optically stimulated luminescence dating, measuring how long grains of sand had been buried since their last exposure to sunlight. Results from Oxford and Cologne universities showed that dunes began to cover the old riverbeds between 5,500 and 4,500 years ago, exactly when the Green Sahara collapsed. But evidence didn't just come from the desert. Far away, in ancient lake beds, researchers drilled deep sediment cores, cylinders of mud that record thousands of years of environmental change. Within these layers, scientists found a sudden spike in Saharan dust around 5,000 years ago, showing exactly when the region turned to sand. Across the Sahara, thousands of ancient artworks tell the same story. Petroglyphs and cave paintings show the landscape's slow death, from lush savannas full of wildlife to barren scenes of herders and livestock. These images, preserved in stone, are both history and warning. Each discipline, geology, archaeology, climatology, adds one more layer to the same puzzle. When all the data are overlaid, the story of the Green Sahara becomes clear. A lush ecosystem created and destroyed by the rhythm of Earth's orbit. When scientists fed these orbital patterns into advanced climate models, the results matched the evidence perfectly. Simulations recreated a Sahara drenched by monsoon rains 10,000 years ago, then drying as Earth's tilt shifted back. The models predicted everything, the rainfall, the rivers, and the collapse, without needing human interference to explain it. Still, questions remain. Some scientists argue that the transition happened gradually, over thousands of years. Others believe it was rapid, unfolding within just a few centuries. The truth may lie somewhere in between, a slow drift punctuated by sudden collapses when the climate crossed its critical thresholds. A few researchers even suggest early humans might have played a small role, through overgrazing, deforestation, or land burning that accelerated drying. While the mainstream view holds that orbital shifts were the main cause, it's possible humanity's first fingerprints on the climate appeared right here in the Sahara. Climate models add another layer of verification. When scientists input the known orbital parameters of Earth from 10,000 years ago into sophisticated simulations, the models predict increased rainfall in North Africa without being told about the Green Sahara. The fact that independent models produce results matching the physical evidence strengthens confidence in both. While the basic story of the Green Sahara is well established, significant debates remain about the details and mechanisms. Some researchers argue the transition to desert happened more gradually than others believe, with the process taking several thousand years rather than a few centuries. The difference matters because it affects how we understand climate tipping points and whether ecosystems can recover from disturbances. Another area of uncertainty involves human impact versus natural climate cycles. A minority of scientists suggest that early Saharan populations may have accelerated desertification through overgrazing and deforestation, similar to how human activity affects landscapes today. The mainstream view holds that orbital forcing was the primary driver, with human activity playing at most a minor role, but the question remains open. The exact routes and connections between river systems are also disputed. Satellite radar reveals channels, but determining which rivers flowed simultaneously versus at different times during the 6,000-year humid period requires careful analysis that's still ongoing. Some proposed connections between river basins remain speculative, supported by topography but not yet confirmed by physical evidence on the ground. There's also disagreement about whether the Green Sahara was truly continuous grassland or more of a mosaic landscape with patches of vegetation separated by drier zones. The drying of the Sahara forced one of the largest prehistoric migrations in human history, though the process unfolded over centuries rather than years. Communities that had lived along rivers for generations watched their water sources vanish entirely. Some groups migrated eastward to the Nile Valley, contributing to the population growth that would eventually make ancient Egyptian civilization possible. Others moved south into what is now the Sahel region, bringing agricultural knowledge and technologies that transformed those societies. A few adapted in place, developing the nomadic pastoral traditions that continue today, moving with seasons and following rains that became increasingly unreliable. The Nile communities cultivated crops and built permanent settlements, the first seeds of organized civilization nourished by memory of vanished rivers. The rock art from this period becomes poignant when you understand the context. Later images show fewer large animals and more cattle and goats, species better adapted to arid conditions. The final images from many sites depict only these domestic animals and humans, a visual record of a world contracting around the last reliable water sources, a culture learning to move with the desert winds. Understanding the Green Sahara requires grasping how small changes cascade into massive effects. Earth's orbit isn't a perfect circle. It wobbles slightly over cycles lasting tens of thousands of years. These wobbles change how much sunlight different parts of Earth receive during different seasons. When the northern hemisphere tilted slightly more toward the sun around 11,000 years ago, northern Africa received more intense summer sunlight, strengthening the African monsoon. The feedback loops mattered most. More rain meant more plants, which meant more moisture returned to the atmosphere through transpiration, which meant more rain. But feedbacks work in both directions. Once vegetation dropped below a threshold, the system flipped. Less plant cover meant less atmospheric moisture, which meant less rain, which killed more plants, a runaway loop that turned green to gold. The rivers that once flowed through the Sahara are gone, but their memory persists in the landscape, visible to those who know how to look. Their story reminds us that the world we know is more temporary than we imagine, shaped by forces both vast and fragile. Understanding what happened to the Green Sahara doesn't just illuminate the past. It helps us recognize warning signs in our own time, written in the language of vanishing glaciers, shifting rainfall, and ecosystems approaching their own hidden thresholds.